with Python. Surprise! For AI.
Yay! That's us.
So yeah, I figured this year, with recent event, we would do a simple classification example of Messi or Mbappé. But in order for us to do that, what we will do is we will develop a web app in which there's a part of it that is pre-processing in MATLAB with signal processing, and the part that is detection classification is a neural network that will be training in MATLAB and exporting to TensorFlow. You ready?
Yeah, sounds awesome. Good use of MATLAB and Python together and current events.
Exactly. So the usual crew, Heather and I, will go through this workflow in 4 steps. There'll be data prep, AI modeling, simulation test, and deployment. Without further ado, let's start with the beginning, which is acquiring the data. For this, we can either use the new feature in MATLAB Mobile. So yeah, go check it out.
I'm trying it right
It's
now.
available
All
in
right.
23A.
Excellent.
Or you can also just record it with your microphone. So let's start there. Let me prompt MATLAB. I've done that already. You can retrieve the repo on GitLab. And what I'll do is I will open the first pre-processing MLX. So what you do, you've recorded a bunch of Messi, Mbappé, Mbappé. And what you do is here, you select one, for instance, this one. Audio read. I'm not going to play it for you right now. And you use the pretty nice signal labeler app to detect the signal. So you import the data from your workspace.
Great example of using MATLAB and Python together. This is one thing that is very valuable in MATLAB. So it's a great example.
Yeah, it is. Because this type of thing, I can tell you, I think in Python, I would have no idea how to do that.
And I was working on another audio app using Python and MATLAB together, and I was very lost. It was much easier to use Audio Toolbox and the feature extraction techniques. So this is a great example of it.
So here I just give you one example of a labeled signal. You can automate some of it. I'm not going to go into too much depth, but just to tell you here, we export it and then we extract the signal and we write everything to a folder, audio file, and so on. So that's step number 1. Okay, so once we are done with that, step number 2. Now it's all about setting up a pipeline, an audio pipeline, where you have the signal and you perform some transform, a MEL spectrogram, on which you will train a neural network, all right? And then every time you get a new signal, then it's going to be the pre-trained model. So for that, we have several options. The one that I'd like to use,
I also like this because it talks about all those different options. So you can really use it in different ways depending on how people are going to want to do that. So if they're going to deploy, you can use the converters. If they're trying to develop, you can, go side by side. So I think it's a great example that you could tune to your user base that you're presenting to.
Indeed. Right now, I went straight for an already existing neural network that was YAMNet, but you could go and ask your colleague, maybe they have a TensorFlow version you can import, maybe they have a PyTorch one. You can even go and ask ChatGPT, create me a YAMNet TensorFlow network, right? Now that's the kind of stuff you do. So here it is, you just get it. That's what 2023 will be all about. AI. So Deep Network Designer, just going to go quickly through that. Here we have an option for YAMNet, so I'm just going to use this one, right? So no big deal. Because just as well would have imported a TensorFlow or PyTorch neural network. That would have been nice as well. Now what I do is I will modify it, just the last layer here to change it. Instead of having a bit of over 1,000 classes, what I'll do is, where are the dances? Fully connected. Here we go. So this one here, output size, I just want to have 2 classes, Mbappé or Messi. There you go. Okay. This way around. So you want to auto-arrange, otherwise it doesn't look like much. All right, let's see if we analyze it. Oops. Any idea on how to fix that? Maybe I just remove it and add another one at the end, the sound, so like classification layer, I guess.
Right. And the sound layer, there's, yeah, the output size is fixed, it looks like.
So sound layer, it's a classification layer, it's the last one. I'm just going to remove that one, and here, yeah, it's going to auto detect. So let's just do that, analyze. That's a nice thing also, Deep Network Designer, you just go in iterate, and here you go, 3.2 million learnables. So now what we'll do is, okay, now training, data store. We have ourselves a data store that we just created previously. All right. The transformed one, so the train TS transform trained, and validation TS validation transformed data store. Here you go. So now it's step number 2, data. And here you go import all of it. All right, good to go. What's next? Training. So now you set up the options. Let me remind myself what are the options. Adam, we'll just tune it down, the learning rate, and we'll just do a few epochs. I think 10 should do. So that's about it. Let's see. Oops. Adam, a much smaller learning rate, like just divide it by 10. Max epoch, I think we just need 10 of them.
Yeah, it's good for a demo when you're showing training.
So here you go. Let's train. Shouldn't be too long. And
Of course, this is where you do your dance. But I think, again, this is a really good demo for this reason, because you could have brought in different kinds of models. You could have trained it elsewhere and tweaked it in MATLAB. So I think it's very flexible. Depending on who you're talking to, you can sort of paint the vision, which is great. Whoa.
So as you can see, it's just going to take about a minute. It's extremely fast. We're going to have a good accuracy. I don't have a huge data set. That's also the nice thing about it. You can go and record some more data and go and iterate. So here you go. Now you have yourself your network. You're going to just export this one, train network 1, blah, 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 blah. And we are done. Good. So now what's next? Oh, we can import it into Simulink and test. I'm not going to show that, but that's possible, and you have an option for that. Now what we're going to do is we're going to export it to TensorFlow. Awesome, new feature. So let's do that. First, I'm going to test it inside of MATLAB before I output a TensorFlow network. So blah, 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 we've seen all of this.
And again, this is so great to show, because there are people that might want to read in a TensorFlow network, convert it, do some things in MATLAB, test, and then convert it back to a TensorFlow model.
Exactly.
So yeah, again, it's really good for vision painting, for the whole workflow.
In and out, you can test it in MATLAB. You can test the accuracy, blah, 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 and you can export it to TensorFlow as TF model. So I do have this already, so I'm going to close that. And now let's look at the next step. But for this one, I'm going to switch to Visual Studio Code. Let's open the notebook. So here, what do I have? I have first here, import TF model, which is the model that I just generated. Then what I'm going to do is I'm going to use, and let me show it to you real quick, the way it looks, because you may have never seen that before. So this is what has been generated by the deep neural network. Good. So we import the TF model. We look at it with a summary method. Okay, all right. Looks exactly the same as what we've trained. Now we can use test data with SciPy like this. I've saved test data and just test it. All right, we can do that. Look at the shape of it. I like the shape of it. Just getting test data, looking at the model input size, blah, blah, blah. I'm gonna get here the 4 different elements of the test data. And now I'm gonna do model.predict just with the first one. Then I'm gonna do here, look at which label is it. Okay, so it's Mbappé. That sounds like the right one. So x test of 0 was this one here. Now let's try this one here and see if it still works. So x test 2 and here still good. You can also do the same here with MATLAB engine. And so you'll start a MATLAB engine on the other end here and connect to it. I'm not going to do that just now, but that's an option that is available in the demo. So you connect to it and then you use the audio pre-processing and everything that I've shown before, but from Python.
Again, another good way to adapt depending on the audience's needs, right?
Exactly. Some bugs in MATLAB, that's normal. And now, where are we? Deployment. Last step. So what we're going to do first is we're going to generate a Python package in order to integrate everything into this web app that we want to develop. So let's just go in there and this I want to close. It doesn't want to, but that is fine. Now D is deployment, and let's deploy, no, not this one here, the pipeline with the audio here. So audio pipeline is a function that I've created, and let's have a quick look at it. It's in ML model. So I've stored everything in here. Audio pipeline that is going to call the audio preprocess. So just reading, setting the level to nothing, just audio preprocess is this other function that is doing the YAMNet preprocess, computing the spectrogram, and then we're going to give it to the TensorFlow model. So let's do that. We just package it. Small bits. I think we'll be able to cut this part. Not quite so interesting. Okay, good. So now let's install everything here in this repo, just Python setup.py install. Oops, with an A, not with a Q. It's not a French keyboard. And now let's test the deployment pipeline. So here we have installed this audio app. We import it, which is going to give it this one audio file. Shouldn't have any label at this stage. We cast it to an NumPy array, look at the size, and now call just the same way the TensorFlow model, and look at the label. Here we go. Now we're good to deploy into a web app. And that's the final demo. Let's switch here. Maybe we can speed up those parts, I guess. So let's try with Mbappé. Up. One here. Pre-process it. So here we have
Mbappé. Mbappé.
Okay, we have the data over here of the spectrogram, good shape. Let's predict. Ta-da! Okay, just to make sure that I'm not bullshitting you. Let's try with another one.
Messi. Messi.
Ta-da! Not too bad,
Excellent.
right?
Yeah, very
So
good.
now you could also deploy into other targets like microservices, find the right production architecture that suits you, either monolithic, multi-tier microservice, or something orchestrated by a production server. And thank you. Happy 2023.
Awesome.